Hello, welcome back to another lecture. What I want to talk about in this lecture is using trigonometry for architect, engineer, and actually for everybody. If you never had a trigonometry, it's okay. We're going to start off from the bottom and we're going to talk about the basic, and then we're going to do a simple example. We're going to actually do 3 examples, and I'm going to do one simple, one medium, and one really hard, and how we use trigonometry to our advantage to solve a lot of equations. All right, let's go ahead continue with the right triangle. If we look at the triangle right here, and they call this a right triangle because the angle between these two right here is 90 degrees. That's why it's a right triangle. And one thing about triangle, you have to remember the combination, all 3 angles comes out to 180 degrees. What is degree? Well, degree is we're looking at it, when you look at the circle, the whole circle is a 360 degree in full one rotation. And then if we call something like this one we had on a board, right triangle, that's about 90 degree. And if your angle is more than 90 degree, they call that obtuse angle. And if it's less than 90 degree, we call it acute angle. And if it's bigger than 180, then we can go like a reflex angle. But let's get back to our own. So now when we have this, we like to use, there's 2 things about this triangle you want to learn. One is the sine and cosine function, and then the other one is the Pythagorean Theorem. So one of the things about triangle you really want to learn is Pythagorean Theorem. Pythagorean Theorem allows us to, if we have any of 2 of these legs, we can calculate the third leg, the measurement, how long it is. For example, the Pythagorean Theorem formula is a squared plus b squared is equal c squared. So we use this to our advantage. Let's go talk about sine and cosine. Let me pull up what I have on my screen right here on my PowerPoint. There we go, right here. So now we have a looking at it, we can look at the sine and cosine. When we look at the right triangle here, we looking at the 3 sine and cosine and tangent function. And by looking at this, what we have on the screen here, we have sine theta, which is equal opposite divided by hypotenuse, and cosine theta is basically adjacent side divided by hypotenuse, and tangent theta, which is used a lot really, it's side opposite divided by side adjacent. We will do a lot of example of this to find out how we use this function. All right, let's do an example, and let's make this, this is a simple example. If you're really bored and you know this stuff, just move forward to the next 2 examples, which we get more complicated. And now we have this triangle, and say we got one length is 5 and the other one is 12, and I want to find out what the third length is. Then I want to find out what these 2 angles are. All right, so first I'm going to use a Pythagorean theorem. I'm going to say, okay, 5 squared plus 12 squared, that's equal c squared. So 5 squared plus 12 squared. So if we do that, that become 25 and plus 144, and that's equal 25 plus 144 comes out to 169. 169. So we can go ahead say c is equal square root of 169. So that comes out to square root, come on, 13. So now this number comes out to 13. Okay. All right, now we have found out all the dimension. I want to find out what's the this angle is. So that's beta. I'm going to say sine of beta, which was equal opposite divided by hypotenuse. So it'd be opposite divided by hypotenuse, and opposite is 12. 12 divided by hypotenuse is equal 13. So that's sine beta. And now if I want to find out what beta it's going to be, if you go on your calculator and where you have the sine function down just above it, not on a button itself, just above it, it says sine inverse. So that to get to that, you have to push second and then push sine, and that will get you. So I'm going to go ahead and say sine inverse, which is basically push second sine of 12 divided by 13, and let's see what we're going to get. So I have 12, whoops. Divided by 13, it tells me it's going to be 67.38. So that is 67.38 degree. All right, so now we know that's a 67. I can find alpha easily. All I have to say is, okay, equal 180 minus 67.38 minus 90. Or I could just say 90 minus that will be the same thing. So for that number minus 90, that should give me 22.6. 22.619. See if we got that right. What I'm going to do, I'm going to go ahead and use a sine alpha or cosine alpha, whatever. You can use that and to figure this angle out. Let's use a tangent, okay? So tangent of alpha is equal, okay? And what's the tangent says? If you go back to our thing, it was opposite divided by adjacent. Opposite is 5, and adjacent is 12. And well, let's see, comes out to whatever comes out to. I'm going to just say tangent inverse of 5 divided by 12 comes out to, okay, so I'm going to have second, hit the tangent and hit 5 divided by 12. It gives me 2661. 2261. Exactly same answer as that. So we knew that. All right, so this is how we're going to use, this is a really simple format. Next, we're going to go ahead and pick it up a notch, put some garlic and hot pepper in our soup, make it a little bit more interesting to use these functions. Let me erase this board. Okay, here's our second example. We got this piece of plate, and it's anchored to the wall, and we have these three forces at these angle yanking on this bolt. It could be a weight, could be anything. But we want to find out what is the total resultant of all these forces and how it's going to look. And what we're going to do, the first thing, we can look at the first one. This one is a vertical force at 4 kilonewton. And this one is a force going the other way, 3 kilonewton at an angle of 30 degrees from horizontal. And this one is interesting. They didn't give us an angle, but they gave us something like the dimension of the triangle that we just talked about, which a lot of time when you have something like this, you really don't have to convert this to an angle to figure out the x and y component. We can use these numbers. For the x component, we just use the horizontal, and for the y component, we use the vertical component divided by hypotenuse. So, okay, let's get to work. I'm going to go ahead and make the horizontal x and y component of this force. So let's go ahead like this. This is the f of y. Do it again, f of x. I'm doing good. So this one is going to be basically f of y of this component. This one I already have f of y. We don't have to do anything. Let's do the same thing over here. F of x. And this is f of y. All right, let's figure out what they are. Okay. My marker is giving up on me. I'm going to use different color. So now we have here, this is easy, f of x, and I have this 0 kilonewton. And if I want to x component of this, all I have to do is multiply this by cosine. The cosine closes them in, okay? So cosine 30, it's going to be 3 kilonewton times cosine 30, whatever that comes out to. And this one, it's going to be the vertical component of it, b. There's two different ways we can figure this one out. The easy way, I'm going to say, so if this is my force and this is a 30 degree between here and horizontal, therefore the vertical component is going to be the sine of this angle. So it's going to be 3 kilonewton times sine of 30. There. Now we have those two, or we can just go ahead and say cosine of 60 because this angle comes out 60. Excuse me. This is interesting. The fx component of this one is going to be 3. Remember, the horizontal or the x portion of this is 3. So it's going to be 3 divided by hypotenuse, which is 5, multiplied by 5. And a y component of this is going to be 4 divided by hypotenuse times 5 kilonewton. And this one is just a vertical component, so f of y of this one is equal 4 anyway. So now we have all this done. Let's find out where the resultant force is going to come out if we put all this together. This result, I'm going to say our x direction, our f of r, resultant force of x is going to be, let's start from here. It's going to be 3 kilonewton times 5, 3 times cosine 30. So 3 times cosine 30 plus, and that was for this one. The component of this one is going to be 3 over 5 times 5. 3 over 5 times 5, and that's it. So that comes out to, you can use your calculator to see if you get the same number I do. Hit clear here and on, of course. Five nine eight. 5.598 kilonewton. All right, let's do the y portion. So I'm going to have to going up is positive, and f of r y, and we got to make the sign. So the sign going to right was positive, and both going to the right over here. And here we're going to have going down. So we're going to have one going up actually. So it's going to be 3 times sine 30. 3 times sine 30, and then minus, because this is coming down, so it's going to be 4 over 5 times 5, 4 over 5 times 5, and this one is a minus, minus 4, and that comes out to 6.5. So minus 6.5 kilonewton. The minus sign just basically means the direction is down. Okay, now we have both of these, and we can come in here. So our f of r, this is going to be right here. That's going to be the x, which came out to 5.598, 5.598, and the y came out this way here. Can't see it, but it's going to be 6.5, 6.5 kilonewton. Let me write that down here so we can see it better. So if I have this one coming at 5.598, and this one is coming down at 6.5, okay, our result is going to be someplace around here. Not quite in the middle, more toward this one because this one is a little bit bigger. So that's going to be f of r. And to calculate that, we have a formula. I don't know if I put it on the board, but I'm going to write it down anyway. So f of r is equal square root of f of x squared plus f of y squared. That's a nice looking y. So it comes out to square root of 5.598 squared plus minus becomes square, so anyway, so it becomes positive number anyway. So 6.5 squared. And FR should come out to Come on, calculator, work with me. Okay. 858 kilonewtons, so that become 8.58 kilonewton. So the next thing I want to find out, what I know this angle is right here. Let's call this theta. And again, we can look at this like a triangle. If I look at this triangle, I have this right here, and that's a 5.598, and then I'm going to have this I'm looking for right here, okay? So I'm looking for this FR. This is FR. We know this 598, and we know this is 6.5. Okay, I don't have to find the hypotenuse. I can use tangent. When we talk about tangent, it's going to be used a lot. So I'm going to say theta is equal tangent inverse. What was the thing was? It was tangent inverse. I'm looking for this angle right here. Opposite divided by adjacent. So it's going to be 6.5 divided by 5.598, and $49.3 degree. Okay, so there it is. All right. Okay, so our third problem here right is we got this angle iron which is bolted into the concrete here, anchored in, and we have these two forces at these two different angles. It's tied down to this angle iron, and we'd like to know what's the resultant force of these two forces, which is going to be this way someplace, where it's going to be, and how much it's going to be. And first force that is pulling away from it is at 60 degrees from horizontal is 450 Newton. And the second force, which is bigger, is a 700 Newton at 15 degrees down from horizontal. Okay, how are we going to go ahead and find the resultant force? And we're going to use what we're going to say cosine law, and take a look at what we have on the board. So I'm going to go ahead and redraw this over here. Let's call this X. That's a straight line, by the way. And this is my imaginary Y, so I can see it. I'm going to go ahead and go 60 degree probably right here. So I got one right going here. That's my 60 degree, 450 Newton. And let's say this is a 60 degree. And then I'm going to have the 15 degree down from this angle here. So it's going to be 15 degree here, 700. Okay, made it too long. Now I'm going to go ahead, take this one, pick this one up, tail of this one, put on the head of this one, and continue this basically here. I'm going to pick this line up, and I'm going to go ahead and put it up here. It's going to be, remember, it's 15 degrees down. So if I go a straight line right here, it's going to be 15 degrees down from that. And it's going to be this magnitude. It's going to come in like this, somewhere like that. And we know this is a 15 degree. All right. And I really want to know what this here is. If this is, remember in trigonometry, you learn something like this. Okay, if this is a 60 degree, this is also 60 degree right here. So now we have both of those two. And so now we have a 60 here and a 60 degree there. And this is going to be, therefore, we know that's a 60. So this is going to be right here. It's going to be 60 minus 15, which is equal 45, and that's 45 degree. Now, we pick this one up and we put it over here. Now I'm going to take this one and put it over here. So tail of this one, head of this one. So I'm going to pick this one up and bring it up here, and it's going to be right there. So basically, I took this one and put it over here, and I picked this one up, put it over here, and they meet here. That tells me my resultant force, it's going to be, my resultant force is going to be right this. That's going to be, I'm looking at. So that's going to be a FR for resultant force. And how are we going to do that? Using a cosine law. If this is our C, and we know the angle between both of them, and we know the magnitude of both of them, so we're going to go ahead and use that. So FR is equal square root of, and that was a square, which was this one right here, WAB 700 square plus 450 square minus 2 times 700 times 450 times cosine 45, which is between them. Let me get rid of this right here. And that comes out to 497 kilonewton. Did I do that right? Yeah. So that's equal 497 kilonewton. And now that's our resultant forces. Okay, let's find the angle. So let's call this angle right here between them alpha. And then this from here to here, call this one, this angle right from here to here. I don't have room, that's why I'm going to do it. I'm going to call the whole thing theta. And let's figure out what our theta, our alpha, it's going to be. Using it again, cosine law, we're going to go ahead and say we're going to say sine alpha divided by 700. And then we're going to have, that's equal, we knew this was 45 right here, so sine 45 divided by this magnitude, which we just figured out, 497, and therefore I can go ahead and I know this, I know this, I know this, that's the only thing I don't know, and my alpha, it's going to come out to okay, 9519. See if you can get that, how I got that. I mean, it's easy, really. All you do is find out what sine alpha comes out to, and then you do an inverse on it, and you should come out with that. That'd be good practice for you. So now you find sine alpha is 95. I want to know what is going to be to theta. And it's going to be, we told you theta is from here to here. Basically, is alpha plus 60. Alpha is 95. So theta is equal 60 plus 95.19, and therefore theta comes out to, okay, my brain is not working, 155, close enough. All right, so that's how we find that. Well, I hope this was hopeful to you, and if it was, give it a thumbs up or subscribe, and have a wonderful day.